Okay, this is 11.1. We're starting to talk about, in this chapter, we'll talk about areas and volumes both. So for 11.1, we're talking specifically about areas of parallelograms and triangles. If you will pause the video and copy down vocab, make sure you have the pictures. You know the base is normally considered the bottom, but it's really important to know that for both the triangle and the parallelogram, and really any shape we talk about, any polygon, the base can be any side. Right? You could turn it upside down, then that could be the base. However you look at it, as long any of your sides can be the base. The height, we know another word for height is altitude, which remember is that perpendicular line from the vertex. And the most important part here is that base and height must be perpendicular. So it doesn't matter if you choose which one you choose your base to be, but your height has to be perpendicular to that. And so just be careful that that's really the main factor here. This 11.1 area addition postulate is important, but it's something you know already. The area of a region of the sum of areas is its non-overlapping parts. You know this from like elementary school. You know, you might have had something like this, and it was like find the area, and you would split it up into like a rectangle and then a square, and you would add those together. That's what that postulate is talking about. Okay, so you're going to have two main formulas here. The first one is the area of a parallelogram, which is base times height, just like our rectangle is base times height or length times width. What gets people most of the time here is that the height is, it can be marked any of these places and still be the height. It can be marked on the outside. Sometimes they'll draw extra lines in here, and all of that's the height. So if you see something going from top to bottom, if the bottom's your base, and it's perpendicular to those, then it's the height. Okay. This says find the perimeter, which we know is adding up all the sides, and the area of the parallelogram. Now, in order to do that, we will need some more information, but remember that perimeter is always going to have normal units, and area is always going to have units squared. We will be picky about that. I will count off for that. There's a huge difference. Okay, so check at the end of the problem that your perimeter has normal units and your area has units squared. Okay, and looking at my picture, it's a parallelogram, so we know opposite sides are congruent. We remember that from our days of doing quadrilaterals. And so if that's 20, that's 20. If that's 32, then this whole thing is 32. And so for perimeter, we're going to add that all up. 20, 20, 32, 32. And we get 104 inches. Okay, for area, we need 1/2 base times height. Well, we have our base, 32. We need our height, okay? But if you look right here, you can see this is a right triangle. And we know this part is 12. We know this side is 20. So if we can do Pythagorean theorem to find that side, we have our height. So I'm going to come over here, 12, 20, and we want to find that. So Pythagorean theorem, and you would solve and you would find the height is 16. Now, be careful. I want area, which is base times height, but this is not my base. Right here is a triangle. I was looking for the parallelogram. I've got to go back to the picture and find that very original base. So base times height is going to be 32 inches times the height that we found, which would have been that, which is 16 inches. Inches times inches is inches squared, and 32 times 16 is 512. I want you to pause the video and check your progress 1, and then start it back to check your answer. Hopefully you wrote this problem and you're checking it. You should have gotten B. You can see I did the same thing. Use the sides of the parallelogram to find the others, added them up for perimeter. And remember, that's normal units. Did Pythagorean theorem to find the height there. And then use that as, the height there to find, which is that, and my base as 27, height is 15, because base and height always have to be perpendicular. And that is my area, and remember that's going to be units squared. Okay, another area problem, so base times height. I look at this problem, have my base, right? That's not my height because it's not perpendicular, and it should be. That's my height, that's what I need, but I don't have enough information to do Pythagorean theorem. However, I do have an angle here, so it's a 45, and we know if this is a right angle, this is a right angle. If that's 45 and that's 90, this has to be 45. So we can use a 45, 45, 90 triangle to find the height of a parallelogram. And if you remember, you go from leg to hypotenuse by multiplying by the square root of 2, right? It should get bigger. And of course, vice versa, hypotenuse the leg by dividing by the square root of 2. Okay, well, we know this is 9, so we know this must be 9. This is my hypotenuse. I want to go to my leg. I know it's confusing because this is marked as an H, but it's marked as my height, not my hypotenuse. We know the 9 is our hypotenuse because it's across from the right angle, so that's what you'll pay attention to. So to go from hypotenuse, which is 9, to the leg we need, we divide by the square root of 2, and you know that's not your answer. You'll have to rationalize. Going to multiply top and bottom by the square root of 2. We get 9 square roots of 2 over 2 as our height, which is approximately 6.36. Now we can find the area. Area equals base times height. 12 and 6.36, and we always want to check base, height. Those were the two numbers we had. Those are perpendicular. That's awesome. We get 76.3. I don't have any units here, so we put units squared. That's really important, and that's your final answer. Now pause it and work the check your progress. Okay, hopefully you worked the check your progress. Same thing, we want to go from hypotenuse to the leg, so we divide by the square root of 2. Dividing by the square root of 2 is the same as multiplying by the square root of 2 over 2. All right, that's what happened here. You might remember that from your days. If not, work it out the long way. Totally fine. Rationalize. You will get the exact same answer. Then we came here, 12 divided by 2 is 6. Got that decimal, base, just that was the height we found. Base and height are perpendicular, and multiply them, we get units squared for our parallelogram. Okay, now we're moving on. We're moving on to triangles. First, we have this postulate, and again, it's something you already know. If two figures are congruent, then they have the same area. Well, if two figures are congruent, they're the same size and shape. If they're the same size and shape, obviously, they have the same area. Okay. We are going to do area of a triangle. Now, if you will look, area of a triangle and area of a parallelogram are similar, but that's what gets us confused a lot. If I have a parallelogram, and we know the formula for area is base times height, and then I cut that in half, I get a triangle. And so for the formula for area of 1/2 base times, for a triangle, it's 1/2 base times height, because base times height is for the parallelogram, and a triangle makes up half of a parallelogram. So the formula for a triangle is half as much as a parallelogram, because the parallelogram is base times height. This is 1/2 base times height. Doesn't matter if you do 1/2, if you divide by 2, if you multiply by 0.5, those are all the same things. Okay, we need to buy enough boards to make the frame of a triangular sandbox shown and enough sand to fill it. Okay, if I'm filling it with sand, that's area, right? We're not just going around the outside perimeter, we're filling the inside. So what that tells us is we want to find area, but we also want to know the frame, and that's along the outside. So that's going to be perimeter. If one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and bags do you need? So really, it's not asking for perimeter and area. It's asking us for to find perimeter and area, and then go a step farther after that. So let's find perimeter first. We're going to add up all three sides. And of course, this isn't our final answer, but this is a start, 35.5 feet. Now we need to find area. Well, we actually have our base and height. Now be careful. Base is not this, right? We don't want the base of this white thing. We want the base of the blue. So we're going to use 12. And the height has to be perpendicular to that, which is 9. It does not matter that they don't touch. They're perpendicular to the same thing. And so 12 times 9 for my triangle, sorry, the formula is 1/2 base times height. So 1/2 times 12 times 9, 54 feet squared because we have area units. Now, that's not our final answer. We want to know how much we need. Well, if we have 3 feet long boards, we want to know how many boards it is. Well, if we have 35.5 feet in boards, and each board is 3 feet long, we divide by 3 to see how many we need. Now, it doesn't say, well, dividing you get 11.83, but it's going to be hard to go to the store and get 11.83 boards. So that's not the answer we would give. We would actually say, hey, we need 12 boards. Even if this came out to be 11.2, you would not round down to 11. That is how you would round it. But we don't want to round down to 11. We always want to round up to the next unit, because if we needed 11.2 boards, 11 would not be enough. Now we're going to do the same thing with bags of sand. We have 54 feet for area. Sorry, 54 feet squared. And one bag of sand fills 9 square feet. So 54 feet squared divided by 9 feet squared gives us 6 exactly. So we need 6 bags of sand. Now, that's not the only way to do this problem. I prefer to divide, but you could do like a ratio. So we had 35.5 feet, and we're going to multiply by the fact that 1 foot is 3 boards. So I like set up a ratio, and you can do the same with a bag of sand. We had 54 feet squared, and then I'm sorry, I'm trying to do this while writing, and it's not working. Writing in the car. 1 board was 3 feet. Remember, you know you did it right if your units cancel. And so we had 54 feet squared, and we're going to multiply that by what it told us, where it told us that 1 bag of sand is 9 square feet. And again, we know we did it right if it was cancel. And you'll get the same answers you did there. That's just another way to write it. Where I just divided, you can set up kind of a proportion. Okay, doing great. We only have one more type of problem left. And I highly recommend you draw a picture for these. Notice it doesn't have one. That's helpful. Also, it's a word problem. It's fine. Just take it exactly for what it says. So the height of a triangle, I'm actually going to stop right there, draw our triangle. Remember our formula. Those are good things to start with. The height of a triangle is, so the height of a triangle is meaning equal 7 inches more than its base. 7 more than the base. That's where that came from. Then it tells us the area of a triangle is 60 square inches. So I'm just kind of just jotting some notes down. Find the base and height. So I'm going to plug in. If you want to label this formula, you know this is the height, this is the base. And the height, remember, is the base plus 7, or 7 plus the base. So we're going to plug in area equals 1/2 base times height. Your area is 60. Your base is, look over here, called base, your height